Welcome back. This video is going to cover point measurements of precipitation. Specifically, we're looking at rainfall, and in previous videos we've looked at accumulation gauges and recording gauges. Now we're going to be looking at the errors in these gauges. And the errors can be broken down to several different regions or categories: exposure, representativeness, wetting, evaporation, splash out, plugging, dew, and others. So first, let's start out with exposure, and this is probably one of the most common errors. The air flowing over the rain gauge deflects the droplets falling into the rain gauge. Typically, it's smaller droplets that are affected more than larger ones, and also that increases with wind speed. Estimates have come up with 20% reduction for wind speeds between 5 and 10 meters per second. That would be 10 to 20 knots. And an 80% reduction for winds greater than 10 meters per second or 20 knots. So you can see significantly as the wind increases, the catch is reduced more significantly. And the amount of underestimation, of course, of the precipitation depends upon the drop size distribution, but also the wind speed, and then also the presence of a shield. And it's best to put your rain gauges as close to the ground, because as you get closer to the ground, the wind speed decreases. Also, you want to make sure that the rain gauge is not obstructed by any types of objects like trees or buildings or things like that. On one hand, you want to have some sheltering because it protects the wind, rain gauge from the wind in all directions. But then on the other hand, if it's too close, then it's going to obstruct the droplets falling into the rain gauge. So the rule of thumb is that the height of protection should not exceed twice the distance from the rain gauge. In this example, you see that the rain gauge is, the height of the object is 10 feet, so you don't want the rain gauge any closer than 20 feet to this tree. That's twice the height of the object. Of course, you never want to put the rain gauge on top of the building. You get winds accelerating over the top of the building. Usually, the rain gauge should be mounted just a few feet above the ground, and the ground should be level. To increase the amount of catch that the rain gauge experiences, shields may be used. And there are a number of different types of shields. We're going to look at the Alter, the Tretyakov, and also the Niffer shields. The Alter rain gauge shield is one that has slats that are hanging down that are actually free-moving slats. They can blow with the wind. They're arranged circularly around the rain gauge, and the height is the same height. The height of the slats are the same height as the opening of the rain gauge. And the idea behind the Alter rain gauge shield is to, of course, reduce undercatch or increase the amount of precipitation that is caught by the rain gauge. And try and reduce the amount of wind blowing over the rain gauge, and it forces the air. Technically, what it does, as the wind comes towards the gauge, those slats will deflect the wind down towards the ground and not allow it to accelerate over the opening of the rain gauge. The Tretyakov shield is very similar to the Alter. It's just a modified Alter. And the Tretyakov is used for the National Weather Service on the OBPAG rain gauge sensor, or precipitation weighing gauge sensor, that is located on all ASOS machines or ASOS systems all across the United States. And in effect, it's the National Weather Service standard for shields for precipitation gauges. There's another type of shield called the Niffer. And it looks kind of like a horn, almost like a trombone or something, but it's conically shaped. It's made out of copper. It's put on the top of a rain gauge, and the idea behind it is to prevent the formation of vertical wind eddies in the vicinity of the mouth of the gauge. So hopefully you get a more representative rainfall catch than if you didn't have a shield. So exposure is one problem. Another problem is representativeness. Do you have enough rain gauges that provide you a good sampling of the precipitation event. So you want plenty of rain gauges, and there actually are statistical studies that, many statistical studies that tell you the number of rain gauges that you need for a particular area. The smaller the area, of course, better your sampling. If you have a lot of rain gauges, the bigger areas, only a few rain gauges will produce more misses than hits. Another problem is the wetting, evaporation, and evaporation of precipitation as it starts to fall. Wetting of the rain gauge and evaporation of precipitation. So as rain starts to fall, the surface starts to wet. The surface of the rain gauge starts to wet. If there's a funnel, of course, the funnel needs to be coated with water before the water will flow down the funnel. If the precipitation is very, very light and if the rain gauge is very warm, then you're going to get evaporation and you're going to get losses in the measured amount of precipitation. Typically, the amount of loss is not real significant, but it can occur. And of course, there may be a delay in recording precipitation if the rainfall intensity is very light and the rain event is very short, because of course it takes time to wet the rain gauge or the funnel. Other problems, splash out. This is if you have really big drops. When the drop hits, half of it will fall in, half of it will fall out. So that'll be an under report of the amount of precipitation with big drops. Plugging is another problem. If you have a funnel, then foreign debris such as grass, dead bugs, or other things can clog the funnel. And this picture was taken from National Weather Service report where they had bugs that filled the funnel. And as a result, they were underreporting the amount of precipitation from the tipping bucket. Other problems, if you have a heavy dew is not necessarily precipitation, it's condensation on the ground, but if you have condensation in the funnel of a rain gauge, it may start to coalesce and run down into the rain gauge and report perhaps a hundredth or two of precipitation, so it can overestimate rainfall. Tipping bucket also has problems. We talked a little bit about the tipping bucket problems. At high rainfall rates, you'll have rain that is splashing out or not being counted as the tipping bucket is tipping. And also there have been mechanical failures of tipping buckets as a result of frogs, spider webs, or other things, and so precipitation goes unrecorded. Weighing rain gauges do have some problems. Of course, temperature affects the density of water. So you may have very slight errors as a result of that. Also, you know that rain gauges won't be reporting precipitation while they're being manually emptied. The same thing goes with the capacitance. When it is emptying because of siphoning, it won't be reporting precipitation. They say it takes up to 30 seconds for a capacitance type device to empty. As I mentioned before, temperature may affect the measurements from the capacitance. And then also wind blowing over the funnel, or over the, not the funnel, but the opening, may result in changes in the height of the precipitation, so you get transient errors. So that's some of the errors that you'll see with rainfall measurements.